Drawdown test is one of those simpler tests that is run when a reservoir is recently discovered and it has started with its initial reservoir pressure. So this is the ideal circumstances for this type of test. But we may use that in other situations. So this test is basically used to estimate reservoir permeability and the skin factor. Now, how we run this test. So in this test, we decide about one production rate. And we want to keep that production rate constant. So if we look at the plot of Q versus time, we're gonna have a constant rate. So time 0, obviously it is 0, but we open the well and let it produce at a constant rate. Now at the same time, we are measuring the pressure downhole, and that is actually bottom hole flowing pressure, PWF versus time. And just a moment before we start the rate in this case, we are going to have a downhole pressure which is equal to initial reservoir pressure. And then as we continue producing over time, we expect that our wellbore flowing pressure to drop. So now we have collected data. We have collected the pressure data versus time, and we want to see how we can use this data to actually come up with permeability and skin factor. In this case, we obviously see that this is not a steady state condition. We obviously see that the pressure changes with time. So our first hunch is to refer to the transient line source solution of the diffusivity equation. And let us just quickly review and remind ourselves of the assumptions so that we make sure that the case that we are talking about actually fits those assumptions. So the assumptions were, in this case, we are gonna make sure it's a radial flow, is a vertical well, and the second assumption, obviously, we have a homogeneous reservoir, and then the reservoir is infinite acting. Infinite acting is another term for transient flow period. Remember that when we talked about the reservoir flow regimes and the transient flow condition, we said that if a reservoir is infinite, we're gonna have this pressure wave travel throughout the reservoir forever, and an infinite reservoir is always going to be in transient flow conditions. So if we are having a transient flow, it is as if we have an infinite acting reservoir. Infinite acting reservoir, which is equivalent to transient flow. Now that we have these assumptions taken care of, we'll make sure the condition from the well match these. It's a vertical well in a homogeneous reservoir.